and Android, and illustrating it with some use cases. Give her a welcome.
This works? Okay. This sucks, but it's okay. Yes. No, okay. Okay, I will use this one. Okay. Today we will talk about a more secure world about Android apps. I will tell you a little bit some stories of things that really fail in Android. And we will see some libraries and other strategies that we can make for creating more secure apps. So before a little bit about me, I am Mercesdes. I am coming from Guatemala. I am actually now a leader for two communities, a Google community that is called Plus 502 and a JDuchess chapter. If you are not familiar with JDuchess chapters, these are a female community in the Java ones, the Java users group. And in the past, I was member too of the Guatemala Java users group. Actually, I am CTO in a startup called Productivity. And I am Auth0 ambassador and Oracle developer champion. So we will start a little bit. And before, I don't know if you know this company, Equifax, or listening, yeah. Or at least you listening about it, that one in September of last year. This company don't have specifically a mobile application problem, but they received a really big cyber attack last year. In there, I have here some specific information, but in this cyber attack, the hackers can introduce in their system 38,000 driver license and 3,200 password numbers in their system. After that, on the information that were exposed, we have around like 150 million names, emails. They don't have password, but they have payment cards with their expiration dates. So what's a really biggest cyber attack? And the people now is really paranoid to how we handle their information in our systems. So that includes our mobile applications. And here in the European Union, we have a little bit of more issues with this new law, the General Data Protection Regulation, that is the one that has the fault that we were receiving a lot of insane privacy policy actualization emails in the past months. So if we don't save properly the information to our information, or we don't make the handle of this information in our apps good, we can have problems. And because of that, the last year was ejected a survey with the people, and say to actually now users are more worried about that someone stole their information, personal information in the cloud, that someone entered to their homes for a stole. So it's really critical. The next thing that I will say before to start with the cases and everything is that security is not something that is delegated to our mobile application or only to our backend system. This is a team effort. So we need to make the things right in the Android side, and we need to our guys making the backend, or when we catch the information, make their part too good. So it's not something isolated, so the Android app per se alone will not make to all this will be safe. And first that I will take you, told to you some story that I call the free hamburgers. So once upon a time in a really far lands, that is Ingmar lands, so we don't have much the culture to eat hamburgers. So people eat hamburgers in McDonald's or Burger King. So one person decided open a restaurant that sell traditional hamburgers, no fast food or junk food. And they, well, was so successful that they decided to create a loyalty app. And how works a loyalty app? You enter some code and you catch points, and for every code entered, we catch 10 points, and when we have 100 points, we can redeem a hamburger. This is simple, right? But what could go wrong here? What could go wrong? So usually loyalty programs don't represent any loss in a company. Well, not all people will use the loyalty program. So usually people, when N brought these 10 hamburgers, basically he paid the hamburger that will be gifted to him. But the company start to lose money for the loyalty program. They say, what the fuck we are doing wrong? Exactly. And that question came to the people, what is happening? And now that people of marketing say, our numbers say that it's not about the strategy, it needs to be other thing. So came with that development thing, and they say, okay guys, what can stay happening with our apps, why we are losing money? So think in terms of security, what can be wrong in our application? Same code, yes, they were using the same code in some cases. How? Okay, no brute force. I will show you. And here the problem was how they exposed their API for all the applications work. When I am talking about the API, is this the backend, the REST API for manage. And they have this. Exactly, my friends. This is the worst case of security that we can have in an application. So what they were using, first of all, they were sending everything as parameters. The second thing, they were using get instead of post. And finally, they was not using any SSL or TLS certified. So that means that anyone monitoring a Wi-Fi network can watch that. So what could wrong? So obviously, promotional codes, any single restaurant had one code. So if I have one restaurant in Charlottenburg has one code. If I have one restaurant here in the city box, they have one code, and always use the same code for give points to the user. So with one code that I can catch, I can put to me new codes. Me particularly, I changed 10 free hamburgers. Imagine that. Yes. So, well, but also all the emails and password and other sensitive information were exposed to. So that means that anyone with access to the network, or if I was connected to a public network, anyone can watch my information with the one that I was making, logging in the app, and the username that I have for redeem these points. And obviously, this was happening because someone monitoring the Wi-Fi. I was not part to this application. I discovered this case because a friend of mine is this hackers that is making pen testing everywhere and connecting in every public Wi-Fi and monitoring everything. And he said, oh, I have codes for can redeem hamburgers. Yes. So how we can solve this? This is really simple. The first thing that we need to do is use, well, we can use a combination of things. Just wait, I will quit me this. Okay, yeah, sorry. Okay, with two of these, we will solve that. The first thing is use, obviously, an SSL and TLS certified. That means that our information, we will traverse certified point to point, thanks to the certified in the HTTPS. The next thing is don't use the get. In that, if I am using as SSL or TLS certified, and I am sending all the information as parameter in get, the people will can see that instead when it's HTTPS. So I need to change that for a post, for can modify that, and this information travel hidden and encrypted. For the next thing, the last tip is use better a protocol exchange like JSON. So we will solve that in this way right now, using a post, using HTTPS, and finally sending our information in a JSON. So that means that now this information will travel encrypted thanks to that SSL or TLS certified. So other thing that can do the hamburgers, like he says that if I have one code to one store because a friend of mine works in the restaurant and give me the code, I can add code always. So they can add an extra level of security in their apps and use hell fences. So that means that I will establish a hell fences around the restaurant, and I only will permit to the valid codes, we validate the enter of the code only when the cell phone is inside the hell fence. What negatives or drawbacks have this strategy is that we need to the hell location options we enable. And the next thing is that we have active the permissions for obtain hell locations. And that permit to us pass to the next things about securities in Android. So permissions changed in Android 6, so the ways that we were managing that, I don't know if you know that or yes? Not everybody say yes. But well, in the past, what we do when we install an application, go to Google Play, say I will install that. Google Play say, you know, this app is requiring to you all these permissions. And like the privacy and policies, we say, okay, accept. I don't read anything. I don't know what it's asking me for permissions. And it's installed it. So if they will read all my SMS and what things I am writing there, I give permission. So now that change, and what this change is because permissions are there for guarantee the privacy of our users. So the next thing is that now we have two kinds of permissions. There are the install time and the runtime permissions. So in the past, we only have install time permissions that when the process of installation was made, we give that. But now we have some runtimes, that is that we will ask for those permissions when we are the first time that we will use that permission in our app. And the idea of this is that we can explain to the user why we need that permission in our app. So if I will read the SMS, I need to explain him why. If I will use geolocation, I need to explain to him why. If I will write or read information, save it in the cell phone, I need to explain why I will do that. So here is how happened in the install times. So we have here all the permissions, and here what's simple. If the people make accept, we will install the app. If they do not, that is a deny, we never install the application. Now we have this for some kind of permission, not is for all them. So now we will ask to them if they ask to us permissions or deny to us the permission. If they deny to us once the permission, the next time that we ask to them permission, they will can mark that never want that we ask again. So we will never can ask again to him for obtain a permission. And then I try that and never becomes the pop-up. And the other thing is that people now can go to the system settings and, deny or allow the permissions dynamically. So that means that now in our implementations, we will need to verify that we have the permissions before to use something. So now I have here a little bit of code. If someone is a beginner, don't know that, but in the manifest file is when we add the permissions that we will need. Then this is the way when we check that we have a permission. We use a context. We made the check self-permission, and I am saying which kind of permission I want. And I will say if not is not granted, that means that I don't have permission to that one. And here is an example of the implementation. If I will verify that, and then I will verify if I need to show to him a high explanation or not. If not, this is the way when we may ask the permission to the user. So this is not a talk about permissions. You can go to the official documentation and read more about that. So now we will continue and we will talk about human verification, and this is related with the reCAPTCHA application that was added like 1.5 years ago. So this is for we can offer in our applications the way to people define that is a human. And it's really simple to implement that one. So we only need to go to the Google website and make habilitation of our site. In this case, it's called a site. Then they will offer to us our keys. And then I need to include my, my dependencies. And finally, I will make my implementation here. This is for called reCAPTCHA, and I will verify the result. So this is how this is watched. I have a button, I may click, and they will make that verification, and this is okay. And I test that one, and I am showing you to you this. For example, in this case, I obtain a false, and that happened to me in my app, and this is because I always, when I am making prototyping, I forgot to put the permission for internet. So we will continue, and now, I don't know if you listening about this case. This is for 2014, it's a little bit old, and it's about Starbucks, and was in United States. And what was doing wrong the people of Starbucks in their application? So they was storing the data of their users in a plaintext file in anywhere. So if I have access to the cell phone, I can read all the information saved in this file. They made that, and they sell there the emails and password of the users, and they say that geolocation, but we don't know in that if they save the information to credit cards, because the objective of why they made that is for always to a user want to buy something in a Starbucks through the app, the user don't need to make a login again or insert any other information. They go to the file, verify the file, and catch all this information to the file. So this is wrong. So what was happening here is that they were saving everything in plain text and with public access. So how we can solve this issue? And here we have two things. In Android, for can save information, we can use the shared preferences or use the internal storage. So for shared preferences, this is the way for implement that ones. And here, I think that the problem as usually is when we only are making copy-paste to some tutorial and we don't read really what are doing. If I say to my shared preferences that those ones will be in a private mode, that means that only my application will have access to the information saved in the shared preferences. If I put here that I have a public mode, so anyone can read the shared preference that I have saved there. The next thing is use the internal storage if I want to save that in files. And this is a way to create or open files, and automatically this will create the file in the internal storage with private access. And this is other way, and again here have the restricted access that we can put public or private mode. And we can encrypt the information too, if we want. And for that, Android offered to us since API 18, that is Android 4.3, the Java cryptography architecture. So I can use all them for encrypt information in Android. So what we have here, we have re-implementation to a key store of Java in an Android key store. That is a interface implemented especially for Android that we save things in the trust zone. So that means there is a zone when anyone have access, only our application. And we can use asymmetric keys from the API 18 or unsymmetric keys from API 23. So we have here a chart or a table that shows to us all the encryption algorithms that we have since the version that was added. Here we have only the RSA since API 18, and then we have all the rest since API 23. And this is a way, a diagram that how works this. We have our plain data, then I will choose an algorithm and a key or a pair of keys, and I will obtain my cipher data. And this is a small implementation of cipher for made encryption, and this is other implementation for made that decryption to that information. So now talk about the security myth that was the excuse that they give Starbucks in that moment. So first they say that what is better? Have a really useful app that is easy to use for our users, or have something ultra secure that will be hard to use? Well, the myth is before if we can not make friendly user apps and security at the same time. This is a false, this is a lie. The next thing is that they want to make a permanent open session. And I have here this of OAuth. All of us know OAuth, right? That is a protocol for made the authentication process. OAuth started to being cooked in 2006. And the first version officially launched for use was launched in 2010. And the problem of Starbucks was in 2014. That means that exists strategies for those time for create an app that was secure and user-friendly. So what's a myth, what they say for justify his problem? So what happened here is that they made a bad API design. And this bad API design is in the REST API. Is that people that create web services that need to obtain the username and the password, the credentials of the user, in every single request. And this is not needed, right? We don't need to send the username and the password always. We can use a token like establish the OAuth protocol. So this is a diagram for the OAuth. So we have here our client server. In this case is our application. So this will request a token in the authentication process to our authentication OAuth server. So he will authenticate our client and will return a token to our application. So then our application will use this token for identify himself in front to our REST API or our server that provide information instead to send all the time the credentials, username and password. So in that case, we will don't save in the cell phone the username and the password. If not, we will save the token in a secure place, of course. And I don't know if you know the JSON Web Tokens. No. Yes, someone say yes. So right now it's really popular use for this token that will represent users JSON Web Tokens. So we can use them for interact with our backend and the mobile application. So this is an open standard that started around 5 years ago. It's based for send information encrypted in a JSON notation. So how looks a JSON Web Token is like this one. I have a header, and then I have a claims. So both JSON Web Tokens usually are used with the combination of JSON Web Signatures. What happened with that is that anyone can take this token and put in a token analyzer and see which information is sent in there. And they can change that information. So we need to combine that with a signature for the people. If they change the information, they then will not match with the signature. So we have these algorithms for generate signatures, and always will depend of which libraries we choose. And this is how looks a JSON Web Token properly signed. So we have the header, we have the claims, and now we have a signature that will validate all the information that I am sending in the claims. And this is, for example, the content to this JSON that I am showing to you. So I have here in the header the algorithm that I am using and the type. Something interesting about the type is that always is a JWT, and it happens that some libraries omit include this type in the header because always is the same thing. So since we, as usually, are not making only mobile and Android mobile apps, sometimes when we make apps, we make an Android app, an iOS app, and we have two websites created and a backend. And all those then can be implemented in different programming languages. So all of us will use different libraries, right? So we need to choose a library that manage this type in the same way, or have strategies for ignore the type or for add the type. And then this is claims that we have. The claims are in a structure of JSON, and it's all the information that I need for identify that user. So for example, I have here this sub that represent the user, and here they only have the nickname. This scope usually represent the permissions that have this user in my system. And we have an expiration date and other claims. And then this is how the signature is created. They encode the header, they encode the payload, and we have the secret, all them implemented in the algorithms that we choose. So this is our register claims. Our claims are defined because are the most popular used. And two of those ones is First, this sub that I showed to you in the past slide, that is for identify the user that represents that JSON Web Token. And the next one is the expiration date. This is for create tokens that will be expired. This is really common user, for example, in financial application, when I have an expiration time in my application. So, for example, if I spend 10 minutes and I didn't use the application, they will require to me that I make a login again. So when a user opens this app and try to make something, the backend will say, you know, your session is expired and you need to log in again. And we have then the other ones. We can use them, are optionals or not. So what problems can solve the JSON Web Tokens? Are many ones, but are more typical user for the process of authentication and authorization. But it can be used too in federated identities for making information exchange. This information exchange is when I want to send the information encrypted and guarantee that anyone can modify it. But I don't care if the people watch the information or not. It's used too for save client-side sessions. That is when I have websites that have a stateless session. And the other thing is for client-side secrets. And this is the process for made authentication in the authorization. So the first is the authentication process. That is when the people make the login. Our user will make a login. We send a username and password. And our server will create a JSON Web Token with a secret and will return that to the client. And the client will save this token. And finally, the authorization process is always when I send this token in my header, as usually. So the server will verify if this user, well, is a valid user, if his session doesn't expire, or if he has permission for access the information that he wants. And then he will respond to the client if he can access to the information, and will give the information, or we say, you know, you cannot do that. So if you want to know more about JSON Web Tokens and how we implement them, exists this website that is jwt.eu for investigate about it. And I suggest to you this handbook that have to the Auth0 people that is really good. They explain everything in that how use JSON Web Tokens for federated identities, and have a chapter for use JSON Web Encryption too. So for continue, I will talk, this is a case that happened in a bank. You know, this is a really, really fake case. So when we will transport information, imagine that, right? I have an account name, an account number, and a lot of more things. So if the people say, okay, we need to send this information encrypted. Instead, when we are using HTTP, SSL, or TLS certifies, banks are really paranoid about security. So we imagine that we will send that, right? We will use an AAS algorithm for encrypt information. But the engineer of the bank said, we will send that. Okay, what's that? Here comes the question. What could go wrong if we have this structure? We have the encrypted and unencrypted information values, right? So I don't know if you know this term that is reverse engineering. Yeah, in the past, in Android, that was something complicated when we was using Eclipse and not Android Studio, and the people didn't obfuscate their code using ProWare, because anyone can take the APK, take the files for the APK, make reverse engineering, and obtain all the code files. I don't know if you know that. No, you know where is ProWare? Yes, we need to laugh because some people don't know. You know that? Yeah, ProWare works for obfuscate your code, and the people cannot make that. What happens if the people can make a reverse engineer in your code is that they can catch all your endpoints and all the structure of the information that you will send to your endpoint. So they can make attacks over your backend. So here is the same. I have the unencrypted and the encrypted information, and we are in times when we have really powerful computers, and I can run algorithms for discover where is the secret and where is the algorithm user for encrypt that information. So this is why this is a fail in the situation of encryption. So I will continue fast because I don't have much time, but we will run. Then I will talk a little bit about JSON Web Encryption. When I try to talk with the people in the bank, with these engineers that they believe that are genius, I try to explain that. They didn't understand. So I say, I need to use other strategy, and I introduce to them JSON Web Encryption. That is a way to send information encrypted. In the case to their pairs JSON Web Tokens, anyone can take this JSON and put in an analyzer and watch the information that is sent in there. But instead to have 3 parts, that is the header, the claims, and the signature, we will have 5 parts, that is the protected header, the encrypted key, then is an initialization vector, and ciphertext, and authentication tag. And we will show a more biggest JSON Web Token for transfer. And for example, in the header, we will have the algorithms and the encoding user. And this is an example of the header encoded that have more information for can decrypt the rest of the information. And I will continue. Yes. The problem with the user credentials. I don't know if you see this meme, because I think that I stole it from Twitter or from Facebook. Someone shared that one. But yes. What happened with this of the fake credential is that one of the problems that we have actually is that the only options for make login to our users that we are offering is a single signing on. And that requires only a username and a password. And what happened with this is that if someone has sold these passwords, can enter there. Or the people have really weak passwords. So what we do supposedly for solve these issues? So we establish new rules, right? And happen this. Yes? Yeah. Yeah, I will say that these websites that make algorithms to verification if our password is strong or not, sometimes I put a really good, strongest password. Say, no, this is weak. And I put QWERTY123 with the QWERTY in uppercase. Oh, yes, this is so strong. You say, yeah, sure, of course. But it's not, right? So we came to our users to experiment the password nightmare. And we be exaggerated with the rules, like this one. Right? Yes. I wouldn't say which platform, but I know that always that I will make login in this platform, I will suffer this situation. How many of you didn't pass for this situation? Exactly. Why I need to restart? I need to... No way. This is impossible. So this sucks. It sucks a lot, and our users sucks that. So we can make improvements in the authentication process. And exist some improvements that are not so nicely. So now is this one, that we need to make an authentication process when we have something that knowledge, that is the password, someone that we have, I don't have my, okay, I will try to make that fast because it's only 5 minutes. Then something that we have, and then something biometric that is something that we are. So we will make to our user made the login with the username and the password, but then we'll require to him that insert a token, or they made face recognition, for example, or they finally made a fingerprint, especially now with some cell phones that permit to us that. And this is something that now is calling multifactor authentication. And exists other ways to make multifactor authentication that are worse than that. So for example, this, when we receive a SMS, Gmail have that. And once I activate that, until I came to travel and I cannot receive my SMS. You know that? Yes, because not always the roaming works. So I say, fuck, I cannot enter to my Gmail. So this sucks a lot. Then we have this. This is an example. Yeah, there is. This is a way to make multi-factor authentication in a more complicated way. So they may log in with only with the username in the website. Then he will use an application for scan this QR code. So then we say, okay, it's okay, but they finally need to return to the application to allow the access in the website. So this is multi-factor authentication. So we are making to our users make many steps and need to have many things. So this is worse than they lost their password or create a password 123. No way. So now we have options. We have federated identity, and I know that many of you use that one. So what happened with federated identity is in the beginnings to the web, we can, when we have a website or two websites that we will use the same login system, equals we will require to the users that introduce the username and the password in the both websites. So one website cannot access to the cookies to other one for verify that. It's like when we make login with Facebook. I don't know if you see some people implement really good the Facebook login and others not. And how we know that is like if I am logging in Facebook in my browser and I open a website and this website asks me to introduce the username and the password that I have in Facebook, they implement wrong the passwordless, because they are not really verifying that I am previously logged in this browser. If they implement properly, this will not ask me that, will redirect me directly to the load permission to Facebook. So this is something that was cannot made in the past, and that's this is the way when it started these servers for authentication and authorization. In the past doesn't exist, and was a necessity for me to these two websites that are related with the same people use the same server for make the authorization in the authentication and use the cookies in the browser. So this is a more complex diagram, but this is with the permission to both domains can access to the cookies to the other one for can access to the authentication. So this is the federated identity. This is when we offer to the users make login with Facebook, Gmail, that are the most common ones. And then we have the passwordless authentication. Who of you listening about passwordless before? Maybe yes. Someone who uses Slack? Someone's okay. In the cell phone? No? Okay, solo one guy, 2, 3 or more. Okay. Passwordless really means passwordless, without password. Is have the chance to our users to make login without a password. So which strategies exist here for make passwordless? This is one that is not related with anything more than geofences. This is for an application that works as a tool in the office. So they are establishing the fact to if the user makes login and is inside a geofence defined for the company, will access immediately. If not, they will require meta multi-factor authentication. This is a way to make passwordless. This is other one that is with fingerprints. And I put first this diagram because with passwordless, many times we put the username that usually is an email address. So then they scans the fingerprint and automatically we will verify if this user exists or not. So if they don't exist, we will create a user in our system. If not, we'll generate our JSON Web Token and we permit inside the user in our application. And the same happened, for example, with the SMS codes. So they introduce, but with the SMS codes, they previously need to make a register with a password. And it's only when they will make the login that will permit, don't make that with a password, and we will send a code to the cell phone for they introduce that one in our application. And the most common used is the magic link. For that is I was asking to you that of the Slack, because Slack use the magic links. So in this case, it's the same. So the user introduced their email address. If he is registered, I will send a link to their email that will be works for two things: make the verification of the email and permit to him introduce to the web server, to the website or to the application. And it's in the same way. If he is registered, I will validate that. I will call the API and I will send an email and he will click in this email, in this link, and will enter to the website. And I was asking to you to Slack because they have this of the magic link. But Slack, for example, always that I join a group in Slack, I need to create a username and create a password. But then, for example, if I change to cell phone, I can put in the cell phone the email, they will send me the magic link, and this magic link will introduce me to all the Slack channels that I am logging. So for example, if I am registered with an email to 10 Slack channels, I will be inside the 10 channels at once. And for final this talk, I will talk to you about identity management. Who of you listening about that? I think that all of you listening about identity management in that when you don't know that is identity management. So identity management is a step to develop us the part of the sign to the authentication and the authorization and delegate that to a platform as a service. And all of us listening about Firebase authentication, right? Yes. There is for make identity management. So we can have their anonymous authentication. We can make the management to our users in a really small level that is only management, the name, the email, a photo URL, and a password. They provide to us the option to make single signing on, make passwordless for email link and phone number, and then make multi-factor authentication, multiple authentication providers that are federated identity. But Firebase only offered to us the Google, the Facebook, Twitter, and GitHub. And now they have a way to manage JSON Web Tokens, and we can make the verification on the JSON Web Tokens. But for example, Firebase don't permit to us the way to manage roles in our user inside to our implementation. And this is because Firebase was conceived as a platform as a service for mobile applications, but not for enterprise implementations. And this is why Google Auth0 joined the Google Cloud Partners in January of this year for offer more enterprise solutions in the cloud. So they offer to use single, they have more options. I will join. You can make the management, and in this case, you can choose which information you will require to your users for manage them. You can define roles and dynamic roles, and they will verify that for you. They have a more extensible federated identity and a more complex passwordless, and have this multi-factor authentication with the application. So they have all these federated identities. Yeah, sometimes we believe that only Facebook exists there. For finish, we have the enterprise identity tool, and we have some banks that offer to us use their implementations as federated identity. And I will put that slides here. I see that was taking pictures, but was there, and I think that it's time for the break. Yes. For
yes.
show the game.
Yes, I'm sorry, we don't have time for any questions, but
I will be here if someone want to ask things or something.
I just really wanted to hear the presentation. It was great.
Okay, perfect.